Solution Y is hydrochloric acid HCl. Solution Z is aqueous 4-chlorobutanoic acid. The pKa of the solution is this. The pH of both solution is 4.00. Write an expression for the Ka of this compound. Ka, acid dissociation constant, is actually acid dissociation constant is technically Kc.
Yes.
Acid dissociation constant is technically Kc, and so you can start making the first. You should start making the equation. Solution Y is hydrochloric acid. Solution Z is aqueous 4-chlorobutanoic acid. The names are given. So if we start with chlorobutanoic acid, we can make a general equation first. And we know that every acid has a tendency to release H plus. So we know that we will get an H plus here. This will be plus and this will be minus. So if I start writing it, I can write H plus and Cl CH2 thrice CO2 minus.
Yes.
Or Cl CH2 thrice CO2H. So this is EQUILIBRIA, and we have first established that Ka, acid dissociation constant.
Yes.
Write a mathematical expression to describe the relation between Ka and pKa. So it's a logarithm equation.
Yes, minus log of Ka is equal to pKa.
Good. Calculate H plus in solutions of Y and Z. We have made the expression here, and they have given pH. So we can, if we go for pH, it's a weak solution, and we can find the concentration of pH by using concentration of H plus by using the formula
minus log H plus.
it's a inverse logarithm. So when you put pH as 4, so you can use shift button in the calculator to find H plus.
It will be 1 times 10 to the power of minus 4.
Calculate the ratio HCl dissolve in solution Y upon this this second acid dissolve in solution Z. Concentration upon concentration. We have the concentration of H plus. So we can, what formula we can use? Can we use the, was there any formula of pKa? Or if you remember, you can check always the notes. Anywhere we can use the formula for pKa, the buffer the solution for combine the two mixtures, because it seems that he's mixing two acids. One is a stronger acid, HCl, and one is a bit weaker acid.
Yes. So can we use pKa minus log of acid divided by this?
We can take any one of them, the stronger one as an acid and the weaker one as a base, as a salt.
Yes.
Or we can find concentration separately. We have the concentration of H plus in solutions Y and Z. The pH of both solution is 4O. Both solution have the same pH. So we can we can use Ka, pKaz, and then we can use the acid. We have the concentration. HCl is a strong acid. HCl is a, so we made some notes on this. So if it's a strong acid, the concentration of HCl will be equal to the concentration of H plus.
Yes. So it will be H plus squared.
How should we get the concentration of the second acid? He has given us we have the expression for Ka. He has given us pKa. pKa is 4.52 for that 4-chlorobutanoic acid. So pKa is equal to minus log of Ka.
I'm getting 3.01 times 10 to the power of minus 5.
Now what we should do? We got the value is how much? 3.01 or only 3?
3.01.
I have the value of Ka. Now, any relation between Ka and the acid concentration? The formula is written in the first equation. I have the Ka, and what about the lower side, the numerator? I need H plus actually.
We calculated H plus.
Do you remember that even if we write down the equation, the numerators are in the ratio 1:1?
Yes.
So if it is 1:1, If it is 1:1, we can take the the negative ion also equal to H plus.
Yes, so it will be H plus squared.
Good. So if I try to rewrite the equation, it will be H plus square. Why it is H plus square? Because equation is on the right side. It is now, this is the position. I have the H plus concentration and I can put it here. So you have to make a square divided by Ka.
I'm getting 0.018.
Double check the calculation and then divide it. Because the second acid is a weaker acid, but there is a problem because the second acid, chloro acid, is a weaker acid and its concentration is coming more than HCl. Its concentration is coming more than HCl. So there is some doubt in the second answer, this 0.018, because it's a weak acid.
Is it? I'm getting 3.32.
Power
3.32 times 10 to the power of minus 4.
that is better because at least it's coming close.
It will come out to be 0.301.
0.301.
301.
A buffer solution of pH 5 is produced by adding sodium propanoate to 5 gram of propanoic acid in 100 cm cube of distilled water. Sodium propanoate, 5 gram of propanoic acid. Propanoic acid looking to be a weak acid, and sodium propanoate is looking to be a soluble salt. So calculate the mass of sodium propionate that must be used to produce this buffer solution. The Ka of propanoic acid is 1.36 into 10 raised to power minus 5. They need a buffer solution for pH 5. So either we can go for that buffer solution formula, the big formula.
Sure. Can we use the formula which has the pKa?
We can use that formula, and we can start, but we need the concentration of H plus, because the problem is the mass, the molar mass is given.
Oh.
Ka is given, and pH of the buffer is given. So we can go and we can first work out the H plus concentration.
One times 10 to the power of minus 5.
Now you have to use a formula of Ka. We have two formulas there.
Shouldn't we find pKa?
We can do that also, but we can also, the
Okay.
pKa formula was originally this formula. If you look at the notes, this was the main formula.
Okay.
But as Ka is already given, So we can directly use it. Now, how we have the value of Ka, we have the value of H now. So either we go for the same logic, 1:1 ratio and square H plus.
Yes.
We should try to find out the concentration of HA. What is the concentration of HA? 5 gram, no, sodium.
We should find the mole.
Sodium propanoate. They have given us sodium propanoate to 5 gram of propanoic acid. So we can make the concentration of propanoic acid if we take it as HA. We have the H plus, and we can now it's a common ion issue because A minus is coming from the weak acid, and also coming from the soluble salt. Let me mark it here. Sodium propanoate. So look at the sodium is the common feature here. So propanoate ions are coming from the weak acid in a limited number. Propanoate, and it's coming from the sodium propanoate also. So this is my A minus. This is my A minus. So I have H plus, but I don't have a HA concentration. For acid, he has given me mass and volume. Can we make the concentration of HA? Our equation is ready, but the problem is if I rearrange it, I will get Ka. I have the Ka into HA. I do not know the HA concentration, and I have H plus.
The concentration of HA is 0.67.
How come?
I got the moles and then I used N is equal to C times B.
So N is equal to CV.
Yeah.
Concentration. And first you said you found the moles, and the moles you must have found by mass upon molar mass. Mass is 5.
Yes.
And propanoic acid molar mass is 74. So you got the moles.
To be 0.06. 0.067.
Good. And the volume is 100 cm cube. Are you changing it?
Yeah.
How much is the volume?
It will be the final answer will be 6.7 times 10 to the power of -7.
Times 10 to the power
-7. Also, it's 6.7.
6.67, no?
6.7.
Okay, 6.7. So we have the concentration of the acid. Then we can put it in equation number 1. We have the value of Ka, we have the value of Ha, and we have the value of H plus. If we put all the values, we can find the concentration.
Yes. It's coming out to be 9.045 times
But
10 to
is it concentration of A minus?
yes,
9.4?
9.04
9.04
5 times 10 to the power of -7.
Then we find number of moles. They have given such a small space.
Yeah.
It is very strange because the calculation is big.
It will be 9.04 times 10 to the power of -8. So the moles will be
It should be mole into molar mass.
yeah. It's 8.6 times 10 to the power of -6.
Ooh. Answer is very small. Have you multiplied with MR?
Yes.
But answer is coming too small. It means we have done some mistake. Because this number, can you repeat the number?
Okay, one second. It's 8.67
That much is
Time-
fine.
times 10 to the power of -6.
No, this is not. Because this mass is so small. It's not even a laboratory mass. Na? At 8.67 is looking fine. Some mistake is somehow coming. You have to check the calculation. H plus concentration is fine looking. A minus is equation is there, then MR. Number of mole is also fine. Now look at the concentration step. 6.7, 10 power -7. Check this calculation again.
Okay. Oh, it should be 6.7 times 10 to the power of -3.
minus
3.
minus 3. Okay. So we have to check our equation 1 working again. Maybe our power of 10 is changing.
I'm getting 0.086
For what?
for the math, now that I've changed the power of 10.
0.086. It's better now, but still 0.086 is not even 1 gram. Our digits are right, but our powers are actually shifting somehow. What volume you are taking for calculation of C? Are you taking 100 upon 1000 now? 0.1?
Yes.
Check this calculation 0.067 upon 0.1. Can you check this calculation again?
A minus is coming out to be 0.603.
Sorry.
When I put 0.067 divided by 0.1, A minus is 0.603.
No, but what about the C value?
Yeah, 0.603.
0.06.
0.603.
How come? How 3 is coming? It's 0.067.
Okay, sorry. Concentration is 0.67.
Achha, zero concentration is 0.67. Okay, got it. 0.67.
67.
Telling me the concentration is 0.67 and A minus Ka into Ha upon H plus. Ka, how much K is 1.35 into 10 to the power minus 5.
Okay, now I'm getting 0.603.
For A minus,
Yes.
okay. 0.603.
Yes. Times the volume, it will be 0.0603. Zero point zero six zero three.
Acha, it's not 0.6, it's 0.063.
No. The final answer is 0.0603.
After multiplying with volume 0.1.
Yes.
Right. Then into MR.
It's becoming 5.7.
5.7.
Yes.
That looks realistic now. But calculation is being so much changed that we should make a double check. But now the number is looking realistic.
Yeah.
Only one problem, the other mass was 5 gram. It's very close to 5 gram. Salt and acid are having EQ mass situation. But how much is the MR? MR is 96.
Yes.
How much mass you're getting from here?
5.78.
At last, some dilute sulfuric acid is mixed with a small sample of the buffer solution described in B. The final pH of the mixture is close to 1. Explain this observation. Sulfuric acid is a very strong acid. He says pH is coming close to 1. So if I say pH is equal to minus log of H plus, and if I say it's 1 is equal to minus log of H plus. H plus will be equal to 0.1. It's a very strong acid. Now, if the pH has changed, should I say that a buffer has failed? Because the
Failed?
buffer was made on a pH of 5. Look here. And H2SO4, the final pH of the mixture is close to 1. What it means? Buffer is working or buffer has failed?
No, it's not working.
It's not working because 1 is a very high acidity, and that is the character of H2SO4. Is it right that in our standard range, H2SO4 is a very strong acid? Is it right?
Yes.
H2SO4 in a laboratory level, not talking about
Yes.
any standard above a standard acids like aqua regia, etc. But H2SO4 in our laboratory level is a very strong acid. H2SO4 can do that. Now we have to see, actually examiner is asking the failure of buffer. So how buffer is working actually, sodium propanoate and propanoic acid. So it means that the solution is working by A minus. If I talk about A minus, sodium is obviously not presently being discussion because we are not adding any alkali, but we had a flood of A minus. We had a big reservoir of A minus. So buffer, when you have added the acid, the buffer is relying on A minus, which is in the solution which are flooded. On the contrary, H2SO4 is a very strong acid. It also flood the solution by SO4 and H plus ions. Our buffer is also producing propanoate ion and H plus ions. So how this buffer actually would be fighting? So we can discuss the failure. It's sodium propanoate and propanoic acid. So do you think that H plus is reacting with A minus?
Yes, it will.
So it means H plus will start eating up A minus coming from the salt, and it is making HA. The equilibrium shift to left. The equilibrium will shift to the left. But before H plus finishes, A minus would have finished. Because one of them has to go. In chemistry, there's a concept of limiting reactant and excess reactant. If the buffer is failing, our soldiers A minus have gone.
Yes.
A
So
minus
it's the limit.
are
Okay.
all used up.
Yes.
H plus is in excess. Now what will happen when H plus still remain in the solution? If H plus is still in the solution, the pH will shift to 1.
1. Okay.
It means it is a failure of, it's a failure of what? Buffer.
Yes.
Okay. Now you can take out your notes register. One question took a long time, but this happens. We discussed the every